All right. Hello, everyone. Welcome, welcome. Thank you for joining us today. This is our last lunch series session of the fall semester, so we're really glad you could all make it. And we have some fantastic content and speakers for you today. So I won't hold us up too much, but I have one quick announcement on behalf of the Sustainability Initiative, which is that tickets go on sale this Monday for the Climate Cap MBA Summit. In case you haven't heard of the summit before, this is the premier national conference for MBAs, and it's coming right here to Sloan, April 17th and 18th. So we're very excited. You'll get to join 500 other MBA students, business leaders, investors, policymakers, climate tech startups. It's going to be a great experience. So if you want to join us, stay tuned on Monday. If you want to get a head start, you can bookmark the Sloan Group's page with this QR code right there. But if you're tapped into our communication networks, you'll get tons of updates on Monday with the link and more information on Climate Cap. So we really hope that we see you there. And I won't hold us up any further. Today we have a great program. I will introduce our student moderator, Nipin Nath, who will lead us in a great conversation with Kiley today. Nipin brings a globe spanning career in real estate investment and development, having executed transactions across America, Asia, and Europe. After stints in investment banking at CBRE in San Diego, where he closed deals worth over $1 billion, and as a senior analyst managing a $100 million fund for the Light Group in Las Vegas, he turned to entrepreneurial ventures. Through his northward development vehicles in Michigan, Alabama, Louisiana, and Massachusetts, he has demonstrated a knack for unlocking value in overlooked properties. A shopping center in Lowell, a hotel in West Dennis yielded internal rates of return exceeding 400% and 450%, respectively, while his portfolio has expanded to include multiple retail centers. Earlier ventures include developing a 150-bed hostel in Kuala Lumpur and managing 35 million in precious metal trades in New Delhi. Educated at Cornell's School of Hotel Administration, Mr. Nath is currently pursuing a Master of Science in Real Estate Development at MIT's School of Architecture and Planning, while simultaneously writing his thesis on Defense Department supply chains for MIT's Industrial Performance Center. Please join me in welcoming Nipin.
Right, one moment. Emma, thank you so much for the introduction. Welcome, everyone, to the last sustainable lecture for this year. In an industry that contributes over 10% of global carbon emissions, where over 70% of poured structural concrete is structurally superfluous, Kiley Feickert and her team at Forma Systems have identified what might charitably be called an opportunity. Their software, Forma Opt, promises to do in seconds what regular engineering tools might take weeks to achieve. That is, to maximize structural efficiency in design, to minimize material use, and maximize carbon savings. Kiley Feickert is co-founder and chief product officer of Forma Systems, a venture born out of MIT's Building Technology program. Ms. Feickert is a practicing architect with a PhD from MIT. Dr. Feickert has worked on a range of projects, including Google's headquarters in Mountain View and London. Her research has focused on sustainable design and increasing efficiency. Her academic career, she focused on the deployment of environmental policy in building construction, balancing between technological innovation and pragmatic implementation. A rare pairing in an industry that is split between engineers and idealists. So please give a warm round of applause to Miss Dr. Feickert.
Hi, everyone. Thank you so much for that introduction, Nipin. I really appreciate it. I am going to start today by giving a quick presentation so that you can see a bit more about my background before we join the conversation in a few minutes. So give me just one moment. All right, are you able to see that okay? I hope so. I can't see anyone. Okay, excellent. Great. Yes, so thank you all so much for being here. I know that it is a crazy time in the semester. As Nipin mentioned, I did my PhD and master's at MIT in building technology. So I'm very happy to be back. I wish I was there in person. But before I get into what we're working on at Forma, I wanted to give you a really quick overview of my background and what led me to MIT and ultimately to the work that we're doing now at Forma. So prior to coming to MIT for grad school, I worked as an architectural designer at Bjerke Ingels Group. I was really lucky to get to work on some amazing projects, including Google's headquarters in California, which you can see here. So in this project, I worked primarily on the canopy or the enclosure, as well as the structure. And I also worked on Google's headquarters in London on this project from conceptual design all the way through construction. And on this project, I led the design of the structural packages, which included the precast concrete, the steel, and the cross-laminated timber or CLT packages. And so you can see those on site here on the left. You see the interior of the Google workspace with all of the exposed structure. And then there I am on site on the right. And I'm really grateful that I got to work on these projects, particularly because Google had really ambitious sustainability goals. For example, they had really high targets for indoor air quality and daylight, as well as material use. But something that really stuck with me as I was seeing this be built on site was just how much material we consume in construction. And so that ultimately led me to want to come to MIT to research how we could reduce material consumption and ultimately the carbon footprint of construction. And so something that, has always surprised me is that concrete is the second most consumed material on Earth after water. And yet, up to 70% of the concrete in a typical building is structurally unnecessary. And so, we often get the question, that's quite a shocking figure. Like, how can that be possible? How can we be building buildings with 70% extra concrete? Most typical concrete floors, including ones that you see on campus, for example, in buildings 1 and 3, if you look up, they're designed to be flat, which means that you have to take the worst case scenario for the loading conditions and then design the entire floor for those conditions. But a floor doesn't necessarily need to be the same amount of material all the way throughout. In fact, if we were to just put material where we needed it, according to the internal forces, you could shave away essentially 70% of the cement and steel, which you can see in this image here. And then because the floors become much lighter, it also means that downstream elements like the beams and the columns, as well as the foundations, which you don't see in this image, can also be lighter. So the whole building uses a lot less material. And so why aren't we designing and building with shape optimized floors more commonly? Well, today there is a labor shortage in the construction industry, and manufacturers lack the time and especially the tools to design more efficient products. The way that they typically work is by using engineering spreadsheets, like you can see here. or software, but they essentially work by inputting design conditions like the loading conditions as well as the material properties. And then typical sections are tested for compliance. So it means they're checking to make sure that it meets building code and all of the safety regulations, but they're not optimizing the design of that product. And so it's not very good at handling different geometry or different designs or allowing engineers to really like explore all of the possible design options. And so at Forma, we're developing optimization software that allows engineers to input their manufacturing constraints, which is a huge driver, and then choose a metric that they want to optimize for, whether it's cost or weight. And then we produce fabrication-ready designs as well as highlight what the savings are for the metrics that they've chosen. So the way that it works in a little bit more detail is manufacturers, in our case, precast concrete manufacturers to start with, input their local building code. So all of their local safety regulations, their material properties, and their manufacturing constraints, meaning like what are the molds that they typically have in their fabrication facility. And then they select what they want to optimize for. We're really motivated by carbon. Often our manufacturers are optimizing for cost, which makes sense. They can also optimize for things like material consumption. For example, if a steel tariff is put in place, they can minimize the amount of steel while meeting all of the building code requirements and safety requirements. And then the kind of secret sauce of our software is our iterative constraint optimization algorithm. And this was really born out of the PhD research of one of my co-founders, Mohammed Ismail, advised by Professor Caitlin Mueller, which we've continued to kind of build out as we've been developing this software, which then allows someone to iterate through hundreds, if not thousands, of designs in order to see what best meets their optimization metric. And then we produce a report of the structural checks so that a precast manufacturer can then fabricate the product at scale. And this was all born out of a research collaboration where we used our software to design and engineer a full-scale prototype for Mextropoli, which is an architecture festival in Mexico. This was in 2022. And here, if you look at the concrete in the pavilion in the center there, you can see how the concrete has been shaped, the concrete beams. And this shaping allows us to save 50% of the reinforced concrete compared to the typical beam and block floor system. And this project really led to our first paying customer who saw the prototype and asked if we could develop a similar system for them. And they're now manufacturing one of our products. This is my co-founder, Edu, here at scale, which saves 16% of material with a 6-month ROI. And so this is a photo of our team in front of that pavilion. At the time this was taken, we had no idea we would spin out to form a venture. As I said, this was kind of born out of a research collaboration, but when we were approached by the manufacturing customer in Mexico, decided the best way to bridge research and the industry was really to spin out and be able to provide these to folks who are building products across the globe. And so here is an overview of our current team. We also recently hired Dr. Keith Lee, who is our head of structural design and engineering. We all have backgrounds in architecture, structural engineering, construction automation. And the thing that really kind of brings us together is a shared mission to improve access to affordable construction and to reduce carbon emissions. And so the reason why we're trying to deliver on shape-optimized concrete floors in particular is because of the potential climate impact. If we were to deploy shape-optimized concrete floors, we would have the potential to achieve a total annual global emissions abatement of 1.86 gigatons. So just to put that into scale, that's about 2 times the total emissions of the aviation industry each year. So it's a huge opportunity for savings while also producing a low-cost product that's available globally as well. So in addition to our first paying customer, we won MIT's Climate and Energy Prize last year, and we recently won an Innovate Mass grant from the Massachusetts Clean Energy Center, which gives us around $450,000 in non-dilutive funding. So the team has now all graduated from our PhD programs and are all working full time on the venture, which, these prizes really unlocked the ability to be able to work full time. And so our partners for Innovate Mass, what's really cool about the Innovate Mass grant is that we work with partners in the industry to build a demonstrator project. And so we're very lucky to be working with JP Carrera, who are a family-owned and operated precast concrete manufacturer out of Vermont, who have built a lot of the buildings that you've probably seen around Boston and the seaport. And so we're currently working on a full-scale demonstrator project that will be deployed in Boston for folks to see in person in order to try and raise awareness around our tools and also get industry buy-in. And so I'll stop there for now. We are just getting started. We're very excited to continue working to shape the future of sustainable construction. Here you can find a link to our website. And just wanted to also plug that we're hoping to participate in the Disciplined Entrepreneurship Lab during IAP, which the Sloan folks are probably familiar with. So if anybody's interested in joining us, please feel free to let us know, and happy to open it up for the conversation.
Kiley, thank you so much for that introduction. That was very, very helpful and very well done. We'll just start off with some easy questions, I guess. The construction industry is notoriously conservative and resistant to change. How do you convince a traditional concrete manufacturer to adopt your optimized designs? Simply put, what is the pitch here?
Yeah, I mean, it's a great question. It is something that a lot of folks in the industry reiterate to us as well, is the kind of conservative nature of construction and of manufacturing. For us, we're really motivated by reducing climate impact, but luckily by reducing the amount of material that's going into a product for a manufacturer, we're also directly reducing their cost. So we save them on their bottom line. And so it's beneficial to us, but also beneficial to them, which is great.
Well, just to follow up on that, I had a question on liability. A structural failure resulting from a novel, highly optimized design is an existential risk for a firm. What specific insurance, indemnification, do you have for a chief risk officer, especially because you're using a proprietary algorithm here?
Yeah, so that's also a question we get a lot, particularly from investors. In our case, one of the main features of the constrained optimization algorithm is that every design that we're producing is designed to meet building code. And what that means is we're doing the exact same structural checks across our product as folks are doing for typical products. So it includes all of the usual safety factors. And that's what the kind of goal of the structural report that our software produces is to ensure folks are convinced about the safety of the product. And on that point, in order to, before even going into the venture, we've done quite a lot of full-scale testing to ensure that it's meeting the structural performance that we would expect it and that we're predicting it to meet, which it has. And so in that case, because we're meeting building code, it is essentially the same kind of sign-off process as any other engineering design.
Oh, that's very interesting. If we're talking about building codes, maybe we can jump into some of the regulatory hurdles that you guys would be facing. Building codes were definitely not written for shaped concrete beams. Structural codes like ACI 318 and Euro codes, which I'm sure you're familiar with, are primarily written for prismatic traditional elements. When your designs produce highly non-prismatic organic geometries, how do you handle the technicality of approvals, basically?
Yeah, so it follows on nicely from the last question because, as I mentioned, all of the designs that we're producing are designed specifically to meet, as you mentioned, ACI 318, which is the structural concrete building code. And so we're doing all of the same checks, which in this case are calculating the shear envelope, the moment envelope, and ensuring that our geometry meets the structural performance requirements of a typical element. And so we're running through all of the typical building codes and able to demonstrate that in the structural report.
Oh. You won MIT Climate Prize. Congratulations again. That's a very, very big deal.
Thank you.
How do you go from prize-winning startup to billion-dollar company? What's the roadmap here?
Yeah, I mean, it's as I mentioned, when we built the first pavilion, we didn't have the idea in mind to commercialize the venture. I think when the first customer approached us asking if we could optimize their design, it really shifted our perspective on how we might bring our technology and our research to the market. Climate and Energy Prize was really, really fundamental in giving us the time to be able to bring it to market. As I said, we were all working on it as full-time PhD students. And so that was that was definitely a limiting factor in being able to commercialize, was trying to finish the PhD and work on the venture at the same time. And so now that we had that funding, it kind of gave us the confidence to not look for jobs after our programs and really just focus on the venture full time. And then luckily, we also secured the Mass CEC grant, which, helps us sustain the team as well. In terms of next steps, right now we're focusing on single product optimization where, we have the opportunity to save 20 to 30 to 40% of a precast concrete element. Our long-term goal is to be able to optimize an entire building. And because of the way that design decisions in terms of column spacing or configuration all are interrelated and directly impact the total amount of material you need in a building, when we can scale up the software to do full building interactions, we think that there's huge potential for savings and think that the amount of value we can bring back to our customers is also immense. And so our goal is to get from product scale to building scale, and that's kind of our long-term scaling vision.
Interesting. Let's talk about competition here. There are other companies working on low carbon concrete, which again, I'm sure you're familiar with. Carbon Cure is one. Why Forma Systems versus low carbon concrete? Why the chemistry versus your optimization?
So I don't think it should be either or. I think it should be both. I am definitely, and folks often will ask us, like, why not timber? Again, I think it should be both. I think that in order to address the climate crisis, particularly within buildings, we need to do as many things as possible, as quickly as possible. But I love the question around the cement chemistry. One reason to deploy shape optimized concrete structures today is that we can build them at scale and save around 60%, up to 60, 70% of material today. We're really excited to see where cement chemistry is going. We're also really excited to see what Sublime are doing, also in the Cambridge area. But as far as I understand, the scale of deployment is still limited, and will take a couple of years, 5 to 10 years um, to deploy at scale, for example. So our kind of response to that question is let's do what we can now to save as many emissions as possible because we still need to be building, in this case, 60% of material. And then when we get to a place where cement chemistry can be, like clean cement chemistry can be deployed at scale, let's incorporate it into the shape optimized products because then we don't need as much of it to build the same amount of floor area, for example. And then just one more point on that, the kind of timber versus concrete question. Um, One reason, some folks think we should stop building in concrete entirely. Um, Timber is not available across the globe. We're really lucky in North America and in Europe to have access to timber. There is still a cost premium to build in timber, so it's not necessarily the most affordable option, and it's also not available throughout the globe. And so we think, you know, it's predicted that cement and concrete consumption is going to grow over the next 30 years. So we think we should be using it as efficiently as possible.
Just building on that a little bit, an optimized form that saves 50 to 60% of the concrete volume may require 100% more complex formwork, sorry. This may require more specialized labor, more training. How do you balance that you're just shifting the costs from, the concrete just to the formwork?
Yeah, so this is something we've spent a lot of time looking at. One of our co-founders, Sandy Kurth, has done loads of work on construction automation, 3D printing at building scale. And we thought that that was actually going to be the biggest hurdle, was getting manufacturers to fabricate the more complex geometries. Um, what we found is that particularly in precast concrete, they already know how to make really crazy shapes. Like if we look at, I think it's Little Island by Heatherwick Studio in New York, that's all precast concrete and it is, complex curvature all over the place. So most precast manufacturers have um, like a carpentry or a fabrication division within their manufacturing facility, and they're used to building inserts that can go into the molds in order to make more complex shapes. So one of the main reasons why we include manufacturing constraints in our constraint optimization is that it allows manufacturers to start with the geometries that they already fabricate and then subtract from those geometries, meaning they can use their existing formwork and just build some smaller inserts that go into that formwork rather than creating custom one-off formwork for every single project.
Thank you. We'll jump back to competition again. The AEC software market, as you're well aware, is dominated by giants like Autodesk, with massive user bases, deeply integrated platforms, significant R&D budgets. If the core innovation at Forma is generative shape optimization, how does Forma Systems plan to defend from an incumbent, adding the same feature?
Yeah, it's something that, I think every startup is concerned about just scale and manpower. I think that in our case, we've spent about 10 years developing this software. It's kind of the culmination of 5 individual PhDs here at MIT. So we've spent a really long time getting to a place where it's feasible for the construction industry to be able to do this. It's a really hard problem. Um, we really think that that's our moat, is our team and our ability to also be connected to the Building Technology Lab here at MIT, as well as other folks at MIT, to bring in top talent to continue to build on our existing framework.
Following up on that, Kylie, how does this work in the BIM workflow? Is it easy to plug it in?
Yeah, so great question. That's something that
Sorry, just in
oh
case
yeah, go for it.
BIM is building information modeling. Like it's a system we use in construction all the time. So
Yeah, and so that software is often an integrated model where all of the kind of parties on a construction project are working together and can see what other contractors are doing at the same time. So because we're starting with the product scale, um, we are focusing on integrating within the precast concrete engineering kind of software workflow at the moment, which is more commonly taking a BIM model and using specialized engineering software to do the detailed design, which then lives in the BIM model in a more kind of simplified version. And the engineering software is really to get a fabrication set of drawings. So that's where we're starting. But the goal, as I mentioned, as we scale up to the building scale, is really to be able to take BIM as an input. So the structural engineer's full building model and use the span, so the distance between the supports, as well as the loading conditions for the different types of program that are in the building, for example, office versus corridor, use all of that information that lives in the BIM model and have that directly input into our software in order to optimize at the building scale. So the goal is definitely to integrate within BIM. Right now, we're starting small in the kind of precast engineering workflow.
thank you. Let's just focus on capital now, which every founder has fundraising hurdles they want to go through. At this stage, what is the capital intensity of the business? Are you investing more in manufacturing, or are you focusing just on the software side of things?
Yeah, so I think our dream would be to ultimately have our own fabrication facility and be producing shape optimized, low carbon building products. As you mentioned, that's quite capital intensive. So that's more of a long-term dream. We've been very strategic to be as scrappy as we can. And what that means is that we, as we were doing a lot of our primary market research, we were trying to find a niche that is going to be very valuable to our customers, but at the same time, something that our core team already knows how to build. And so because we're building on, years of PhD research, we have really narrowed the scope to be able to produce something that we know we can build all of the components of. And of course, the dream is to scale up the team and be able to scale up the product offering. But we've kept the kind of overall organization really really strategic in order to limit our overhead. And so building software also allows us to do that in a way that is very different than getting into manufacturing, building a full scale facility, and trying to disrupt the supply chain or insert ourselves into the supply chain. So we really think that our best way to market is to form partnerships with manufacturing folks who have, been around for many years and know everyone across the value chain, get them excited about our products, and then be able to scale in that way.
So are you currently still with the 5 PhDs, or have you expanded the team at all at this point?
So our core team is Sandy Kurth, Edo Gascon Alvarez, and myself, as well as our recent hire and also building technology PhD, Keith Lee. So we're the core team, the four of us, because we're doing quite an intensive tech push at the moment to bring the product to the customers. And then we're advised by Professor Mohammed Ismail, Professor Caitlin Mueller, and Professor Les Norford. And then, yeah, so we're planning to do a pilot with customers in the beginning of the year. And then, depending on how that goes, would love to scale up the team.
If you get in touch with Professor Mueller, please tell her I say hi. It's impossible to get in touch with her.
I will, I will.
Um, Considering we're at the business school, we're going to get into some businessy questions, I guess. Just on a per project basis, what do you feel are the economics? I know it's very broad, but let's just say we do a 100-unit affordable housing project. What is Forma's take, and how can we save the developer some money here?
Yeah, so because it depends quite a lot on the scale of the building, the size, what products being used, all of these things. It's hard to say for sure, but what I can say for sure is that if we take a modest estimate, for example, saving 20% of material costs themselves are usually around 30% of the product cost for a precast manufacturer. And so saving between 20 and 30% of material saves them about 5 to 10% on their total product cost. So it directly benefits their bottom line. And then one aspect that we haven't quantified yet, but we're looking forward to kind of working through with the Mass CEC grant is because the floors become much lighter. As I mentioned, the downstream building elements become much lighter, but it also means that transportation, installation becomes easier. So, for example, trucks can take either more pieces or don't have to be as heavy. Cranes can either do less number of lifts. So meaning like because the piece is bigger, you don't have to pick as many pieces up to construct the building, which saves a significant amount of time. Or they can use a smaller crane, which also saves a significant amount of cost. So that's what we're kind of looking forward to quantifying as we're working through the full demonstrator project.
Interesting. Thank you for that. I have a question on the modeling, the software.
Mhm.
Concrete is, of course, time-dependent material. It's affected by creep, shrinkage, temperature variation, all of which alter, of course, internal stresses over a structure's lifetime. How does Forma Ops Engine successfully and accurately model and optimize for these long-term time-dependent effects?
Yeah, so it goes back to working with the ACI 318, which is the building code, as well as the precast concrete handbook, design handbook. Again, all of those are kind of captured in the engineering equations that we use as part of our optimization process.
This is a question close to my heart. If anybody has built anything, they know GCs don't always listen to you. If the general contractor decides to deviate from the optimized design mid-project, how rapidly can Forma's op rerun the analysis to provide a new compliant solution without halting site work?
Yeah, I mean, we as you mentioned in your intro, the thing that is, extremely powerful about this tool is its speed. And because we can take in input parameters, for example, if material properties change or if the geometry changes, it's a matter of inputting these new values and within a matter of minutes, being able to get new product designs. So I think in that case, I would be more worried about the delivery schedule for the fabrication than the actual engineering time, which could be, very fast.
Following up on that, we can jump into speed of construction.
Mhm.
Does dealing with such complex forms delay construction schedules, or have you seen it stick to the same, or maybe even make it faster?
Yeah, our goal is to meet current schedules. That's also why we're using existing formwork geometries as kind of the starting point. Of course, as we can reuse, like, for example, the inserts that go into the molds to create the different geometries, the more we can reuse those, the faster it is to produce the product. But that's something that we hope to look at again at the building scale, which is how can we group different slab types together as much as possible to understand the kind of trade-offs between more complex geometries, like different slab types, for example, and saving material versus kind of clustering them in a way where you're doing less custom geometries, but saving less material or less engineering time. So that's another kind of powerful aspect is the ability to evaluate these types of trade-offs, and kind of exploring what we call a design space that tries to capture all of the metrics that you care about so that you can look through many options, not just arrive at like a single option, for example.
Thanks. You had mentioned about, over-engineered slabs and weights. I'm going to ask you the opposite of that side. Forma is built to optimize. If your design pushes the limit of material efficiency, does it leave less room for error or unforeseen events?
So yeah, great question. I think that because we're designing again everything to code, it accounts for all of the typical safety factors. So the at the end of the day, it's providing the exact same structural performance as a flat slab. It's just using that material in a more efficient way. One thing that has been brought up and is something that we, have thought about quite a lot is what does this mean for kind of future proofing or designing for really long term? We've seen, another kind of great approach to reducing carbon emissions, especially in the built environment, is to reuse the buildings that already exist. So adaptively reusing the buildings. You see that in the Met Warehouse, which will be the new home of the School of Architecture and Planning. So yeah, there's this kind of trade-off between over-engineering to produce a building that you may be able to adapt from an office space to a warehouse over a 100-year lifespan versus using only the amount of material that you need today. One thing that we found is that for the most part, buildings don't last 100 years, even though they are structurally viable for that long, even up to 200 years. And longer, we've seen historic examples of concrete buildings that have lasted much longer than that. And the driver there is really economics and the value of land and folks, demolishing a 50-year-old building to be able to build a new building, which they can sell for higher unit prices. So we think that because the climate crisis is so urgent and we do need to be building, that we should be using material in the most efficient way possible, and that those buildings can be reused for the same type of occupancy, like office, for example. Yeah, we wouldn't necessarily be building an optimized product for an office that then could accommodate a warehouse down the line just because the loading conditions are so different.
I'm sure you've compared, but using traditional methods versus your optimized forms, does that have any difference in terms of natural disasters in the structural integrity? I know you're building to code, but the other ones are, let's say, above code. So have you tried to model that at all to see?
Yeah, so great question. We actually love that question because with earthquakes, for example, the amount of force that a building experiences with an earthquake is directly related to how massive it is, so how heavy it is. So in this case, by actually reducing the mass of the concrete, making the building lighter, it means that that building is going to experience a lot less of the forces from an earthquake than if you were to build a much heavier building. And so we do see an argument for using this in seismic zones, also areas that are prone to fire, for example, where, we can use a really light system and still make sure that the architecture is, resilient for these natural disasters.
I'm going to ask one last question before we open it up. Forma came out of MIT's Building Technology program. In your mind, how important was that program? Maybe we can get some of the business folks in there, versus you would have pursued this yourselves anyway.
Yeah, I mean, I feel very fortunate to have had the opportunity to study in the building technology lab. Um, what brings everyone together is a shared sense of wanting to reduce the climate impact of buildings. So it was kind of a room full of people who all believed that, we need to bring more sustainable approaches to the built environment. So as a starting point, it was already a good sign. Um, and then although everyone is working on their individual research, there are also opportunities where we, worked on these kind of collaborative research projects. And so I don't think Forma would exist had it not been for the BT lab, um, especially because, as I said, it wasn't an idea that we had to commercialize from the get-go. It was really a research project that, we had an opportunity to build at scale, and then a manufacturer approached us. And so the other thing that was really quite special about our team is that we had all been collaborating for about 5 years throughout our PhD before spinning out this venture. So we knew we worked really well together. We also had different backgrounds and expertise, like coming to the team together. So yeah, I feel very lucky to be working with the folks that I'm working with. And the building technology lab is just a special place. So if anybody, gets a chance to stop by or take some BT classes, it's a great way to meet those folks. And just quickly, I want to also plug the programs that we participated in at MIT, because I think that was one thing coming from a more technology research focus to trying to commercialize that research. Being in the architecture department, we didn't really know what all of the opportunities were on campus. And I think as a student, especially at MIT, you have so many opportunities, it's even hard to know what exists. And so happy to talk about that more in the questions. But we, for example, participated in Sandbox, in VMS, and the PKG Center Ideas Challenge. We did Delta V this summer, as well as the fundraising boot camp. I'm trying to think of others that we joined. I'll if I can think of anything else, I'll let you guys know. But yeah, I think there are huge amounts of opportunities that exist. And I know that often the Sloan folks probably know about those in a bit more detail. But for anybody who's coming from a research background, a more technology-focused background, MIT certainly has the resources to be able to support you in commercializing your research, which was a huge opportunity for us as well.
Great, thank you. We are definitely impressed. I can say that for sure. We will open it up to the floor for some questions. If anybody has a question, you can raise your hand. Go ahead.
Variability.
No, they can hear.
Okay.
Ready to.
Oh, you can be heard.
Oh, okay. So variability has always sort of been the enemy of defect-free fabrication. You have a thing in which you insert forms into molds. Depending on the design, the inserts are different. There's not a lot of history, I don't think, of structural concrete done the way you're doing it. And so how do you know that in any particular case, the concrete will fill up, you won't have defects or pockets? Many years ago, I'm not out of this industry, I worked on a project where we injection molded pieces of plastic that had thin cross pieces. The manufacturer had made millions of pieces. We increased the length by 20%, and every single one of them failed because the flow in the mold didn't meet the model. So,
Yeah. No, great question. So the the inserts, like using inserts within the mold, at least in the precast industry, is quite common. So this is the way, like it's not being used right now to shape the products in a way that we're suggesting shaping them. But any irregular precast concrete that you see, and I love the example of Little Island because the geometry is so complex. It is it is the reason that we're starting with precast concrete manufacturers because they have the specialty to know exactly what the inserts need to be, what the shape needs to be, how to fix them within the molds, how to pour the concrete in a way that will reduce the variability that you're mentioning. And that's also a reason why, we've decided not to get into manufacturing, but really get into the software design, which is where we think our strength is. So really working with the precast manufacturers who have that expertise to reduce the variability, as you mentioned.
Go ahead, please.
First of all, thank you. I think what you're doing is really exciting. So it's really great to have you here. You mentioned that you're currently doing like an intensive push to get the product to customers. So I'd love to hear more about like what that pilot looks like. What are some of the things you're doing to get those customers engaged and what success looks like? Yeah, I'd love to hear more about that.
Yeah, thanks for your question. Yeah, exactly. So being a part of Delta V was really kind of pivotal for us in terms of identifying what our product should be. I think coming from research as well, we almost came into Delta V with a product that we thought people wanted, but hadn't spoken to anyone yet, which is like, business school 101. So I think that was really helpful to us was to just talk to as many folks as possible and really identify what their main pain points were, in order to kind of focus our product in a way that addressed those more quickly. So what we're doing now, and I have to say the other thing is that we worked in modeling environments that we're very familiar with. So, for example, softwares like Rhino and Grasshopper. Most concrete manufacturers are not necessarily working in those environments. So, a lot of the tech push has been translating the things that we developed in research to a kind of product level, like web-based software that interacts with their current workflow. So that was one big kind of transition, was getting out of our scrappy Grasshopper version, knowing that we could do what we know how to do to a more kind of packaged product. And then, yeah, the other aspect is, as I mentioned, talking to as many folks as possible. So for us, the pilot project is really centered around meeting key performance metrics. So because our whole premise is being able to optimize for metrics they care about, it's how close can we get to optimizing for cost, optimizing for steel consumption, for weight, in order to validate that the thing that we're building is actually useful for them. And then also understanding what exactly the inputs need to be versus what their outputs need to look like, because that's variable for different manufacturers as well. So how can we kind of capture the most folks we can capture, while still keeping the core engine, essentially the same?
Go ahead, finish.
Thank you, Kylie. This has been really interesting. I think it's clear the value prop for the developers, things like transportation costs, like you mentioned. I'm curious what the value prop is, I guess, further upstream for like the concrete producers or the precast manufacturers themselves, where you may have a lower volume of concrete or a more complex precast system. Wondering if you could talk about that a little bit.
Yeah, of course. Great question. So when we were coming into these conversations with precast manufacturers, we thought that the material savings would be enough to convince them. Most of them don't really care that much. It is still 30% of their product cost, so it is still a significant margin. But kind of differentiator that they see as bringing them the most value is speeding up their engineering time. And so they save quite a lot of time on labor, particularly when they receive a new project to bid on. They can very quickly iterate through all of the different design conditions to estimate what their costs are going to be, while also reducing their material costs, which makes them more competitive to win more jobs. So it's kind of there's a lot of kind of value props that we're putting forward. One is reducing material volume, as you mentioned. Second, but I think the most clear proposition to them is reducing their engineering time, so saving labor costs. And then the third is increasing competitiveness for bidding.
Yeah, go ahead, please.
I think what Forma offers to like the future of construction is incredibly cool. I think this might go back to your BIM related question, but I was wondering, like, do you see Forma being more involved in like earlier design process, like before DD, because all the like building systems are very integrated. Like you change the HVAC system, so then the structural like performance of your floor slabs also need to respond to that. So are there ways in which like architects can start using Forma in like concept design, like much earlier in the process?
Yeah, thank you for that question. Because my background's in architecture, so this is a tool that I would have loved to have had as a designer. The way that we've been thinking about it, so short answer is yes, absolutely. We would love for architects and structural engineers to be using this from day one in order to be able to evaluate what all of their options are and see what the savings can be across the building scale. Because often, once a project reaches a precast manufacturer, the design is already settled. It's just a matter of fabricating it and delivering it to site. But what we've seen is that first, the precast manufacturer needs to be able to fabricate it and needs to be able to engineer it and validate that the product is safe, that it's meeting code, that that they can fabricate it essentially. And so that's the way we're kind of thinking about it, is starting with the precast manufacturer, making sure they see value in this approach and delivering them a tool that allows them to design and engineer this geometry, which currently they're not engineering. And then once they're able to fabricate it, scaling it up to something that structural engineers can use and architects can use in order to then specify those materials eventually. So that's our goal. But we didn't want to start with the architects because we didn't want there to be cost premiums associated with this approach if it wasn't something that manufacturers were already familiar in fabricating.
I just want to say my background is also in architecture, and I would have loved to use like Forma and have it under my belt in the design process, but it is very clear like the value add to the fabrication and like the production process. So thank you.
Do we have any online questions? No? Okay. Go ahead.
There is a red flag which is in my mind, getting back to the question with the gentleman behind me. It is all very well. I can see the follow-up that you are saving at every place and in every situation in transport, etc., and saving in materials. But safety cannot be compromised by savings. I think there would be a good idea for you, and you have also shown a slight exit from your, I don't want to use a harsh word, maybe responsibility, by saying, I'm just serving the software and let the manufacturer do whatever. I think it would be a good idea to develop some standardized forms and have them really well tested out and then offer those particular forms to the industry, that these are the particular ones which have been very well tested and everybody can relax. And then maybe later on in years to come, you will build on more and more fancy shapes. But that's a feeling in my mind. I don't know how relevant it is.
Yeah, thanks for your comment. It is one that we hear a lot. And I agree. We are not trying to compromise on safety. That's why we work towards all of the typical safety factors that every building product is designed towards. And so we're building everything to code. We are excited that as part of the Mass CEC grant that we've received, we will be doing full-scale testing, as you said, in order to ensure that what we're engineering meets our expectations in terms of performance.
Sorry, let him go first, and then.
Okay.
Yes.
So my question is related to who is really customer. So I understand your product. I mean, the optimizing the structural design. So it might be structural engineer or designers, but there are a wide range of stakeholders in the construction project, like developers, GC, contractor, designers, and subcontractors. So who is the main customers for you? Who's paying money for you?
Yeah. So today it's the precast concrete manufacturer. And again, it's because the product allows them to speed up their engineering time and save material costs. But we look forward to the time where this product is deployed on site and developers can see that it's saving cost on transportation and installation in particular, because we do think that there is opportunity for the developer to be the one actually specifying or requesting this product on their projects because of the cost savings that they would see, or because of the speed of erection, for example. So today it's precast concrete manufacturers, but ultimately, as the software grows and the product grows, we hope that it scales across the value chain as well.
And we're going to take one last question. Larry, go ahead.
Kiley, for joining us. Could you share a little bit more about how Forma's pricing model works, like how the maybe typical cost to use the software compares with the typical material savings or something like that?
Yeah, thanks for your question. So we are right now using a license per seat, like a typical SaaS pricing model. The main reason we're doing this is because it's something that our customers are already familiar with. They have a budget for external software. And so we're also pricing within the range of what they're used to paying for that, which is typically between $3,000 to $6,000 per seat per engineer. We think the value is much higher than that, especially with the optimization. For example, if you look at optimization software licenses, those are usually around $15,000 to $20,000 per seat. But optimization is typically found more commonly in industries like aerospace, for example. And so I think our current approach, and we're working through this with the pilot project, is to understand what the customers are willing to pay and think it needs to be close to what they're used to paying now. And then as we deliver on returning value, potentially increasing that price over time.
Kiley, thank you so much for your time. I think let's just give Kiley a warm round of applause.
Thanks so much for joining, everyone.